Hello students, in this session we are going to discuss questions from integration and definite integration. It's one of my favorite chapters. The questions in this sheet of both these chapters are quite tricky and they will be too much fun because they're quite tricky. So let us begin. We'll start with integration and definite integration. I hope you all already are well versed with all the types of integration and definite integration. If not, quickly run through all the types because you will need the basics and all the formulas for these questions. So let us begin. We'll take the first question, which is question number 10. Question number 10, students, is actually a direct type. We have a direct formula for this. It is e raised to x into f of x plus f dash x. I hope you have practiced this particular type. In this type, we'll have to make one adjustment for this particular question. We need to create two fractions in this case, students. So what we'll do is we have e raised to x. I'll take minus 1 common in the numerator. So this becomes x minus 2 and denominator is x minus 1 the whole square. Now, students, to create two fractions, the best method for algebraic fractions is we will simply create the denominator in numerator. We have x minus 1. I'll create x minus 1 in the numerator. I'll write it as x minus 1 minus 1 upon x minus 1, the whole square. Now, students, you split this into two fractions. We will get e raised to x into, this is 1 upon x minus 1 minus 1 upon x minus 1, the whole square. I hope you are well versed with the derivative formulas. Derivative of 1 upon x minus 1 is this. And therefore, we can say this is the function. So the answer is minus. It's simply e raised to x into 1 upon x minus 1. You take the minus inside, the final answer is e raised to x upon 1 minus x. So the f of x, which is multiplied to e raised to x, is 1 upon 1 minus x. I hope you got this. We'll take the next question. This question might look weird or difficult because it's 2024, 2023, but students, it's a definite integration question. We'll stick to the most basic property of definite integration, which we use in almost every question. So here, I'll call this original integral as I. I'll mark this as equation 1. We will use sum of limits minus x. I hope you know this rule. Integration a to b f of x dx is same as integration a to b f of a plus b minus x. So it is sum of limits minus x. I hope students already know this rule. So here, students, will be using this rule. Over here, it is going to be 0 to pi. Now, students, sine of pi minus x, I hope you already know it is sine x. So this will remain sine of x to the power 2024. Cos of pi minus x, students, pi minus x is second quadrant and therefore it will become minus and therefore this becomes negative of cos raised to 2023 x. I hope you already know this rule, students. Cos of pi minus x is equal to minus cos x. So we have used that rule, students. I'll mark this as equation 2. Whenever we use this property, we add the two equations. I'll add them. Do you understand, students? The first integral and the second integral are same, but the second is negative of the first. So the answer on addition is 0. I is simply 0. So that is your answer, option A. We'll move to the next one, which is question number 33. Question 33, students. You might find it tricky, but this is actually a past CBSE board question. And it's there in all CBSE books. You have to just follow to the rule, students, and just stick to sum of limits minus x. Now, here when we do sum of limits, 2 and minus 2, the addition is 0. So we'll do 0 minus x. Now, students, you have to understand, when you look at the options also, when you look at the statement 2 also, you'll be tempted to use that minus a to a property, but it's actually got nothing to do with that. So over here, students, this function is neither even nor odd. You can check if you wish to. What we will be doing is we will be using sum of limits minus x. When we do sum of limits minus x, a plus b minus x, over here it is going to be 2 and minus 2 addition, which is 0 minus x, which is nothing but f of minus x. So students, I'll mark this as equation 1. This is my equation 1. I'll call it as I. And when you do sum of limits minus x, it's going to be minus x the whole square upon 1 plus 2 raised to minus x. So now, students, you solve this. This is minus 2 to 2. This is x square upon 1 plus. Use it indices rule. When power is negative, we'll take reciprocal. This is 1 upon 2 raised to x dx. You keep solving the, students. This is minus 2 to 2. When you take LCM in the students, this 2 raised to x will also be multiplied in numerator. So it's 2 raised to x into x square upon 2 raised to x plus 1 dx. This is I. And I'll mark this as equation 2. We'll add the two equations, students. 2i will be addition of these to the denominators are same, students. So I'll copy them. 2 raised to x plus 1. Numerator, if you observe, we have x square in the first integral and this x square can be taken common. When you take x square common, in the bracket, we will be left with 2 raised to x plus 1, which gets cancelled, students, which means we are simply left with integration minus 2 to 2 from x square dx. Now you solve this. Integration of this is x cubed by 3. I expect you all to already know this integration, the basics. And you do upper limit minus lower limit. The answer to the students will be 8 by 3. The statement 1 is true. Statement 2, students, it's a direct property. Even that is true, but you understand statement 2 is not the correct explanation for statement 1. So here, both the statements are true. Option A is correct. Further, students, we'll move to the next question. The next one is 56. The next question, students, question 56 is a very standard question. I expect you all to already know this. Because we have modulus, students, what we'll do is we'll split this into two parts. I'll take minus pi by 2 to pi by 2 as minus pi by 2 to 0 as the first integral, and I'll take 0 to pi by 2 as the second integral. Now, when we take minus pi by 2 to 0, students, we are talking about all the negative values of x and its fourth quadrant. So do you understand, students, the sign mod x will become sign of minus x because these are negative values. From 0 to pi by 2, its first quadrant, sign is positive. So therefore, mod is positive and this is sign of x. So students, this is going to be minus pi by 2 to 0 of sin x plus 0 to pi by 2 of sin x. Solving this is easy, students. Integration sin x is minus cos x. So this becomes plus cos x from minus pi by 2 to 0. And this is minus cos x from 0 to pi by 2. You do upper limit minus lower limit, students. This is cos 0 minus cos of minus pi by 2. Minus, I'll keep it outside. This is cos pi by 2 minus cos 0. The working is easy. If you don't know these values, you can use your calculator. Cos 0 is 1. Cos minus pi by 2 is 0. Cos pi by 2 is 0. And this is 1. So the final answer is 2. Next, we'll take question number 80. In question 80, we have to integrate this. So you might find it tricky, but what we'll do is, it's actually a raised to x formula. If you know integration a raised to x, then this is not that difficult. So this, students, I'll take this function as t. I'll take, it's a substitution based question. We'll assume 2 raised to x as t. Now you differentiate this, students. When you differentiate this, you will get it is 2 raised to x into log 2. And by chain rule, we'll take the derivative of the part which replaces x. The part which replaces x here is this whole part. So we'll multiply it with the derivative of 2 raised to x. We'll keep on using this formula, students. Do you understand? This is again going to be chain rule. So we'll get 2 raised to x. This is again a raised to x, where this is replacing x. So the derivative will be a raised to x into log 2 again, which means this becomes log 2 the whole square. And that is dt by dx. We'll again multiply it with chain rule. We'll take the derivative of that same 2 raised to x, which is again 2 raised to x log 2. So we get 2 raised to x into 2 raised to x into 2 raised to x. Again log 2, so that becomes log 2 the whole cube is dt by dx. So now this question becomes, students, integration of 1 by log 2 the whole cube dt. Once you complete this substitution, log 2 the whole cube is a constant. We'll keep it outside. Integration 1 is t. So this is t upon log 2 the whole cube. At the end, students, you replace the t with 2 raised to x, and that will be your final answer. We'll move to question 81. Question 81 is actually a very straightforward question, students. You look at this f, I'll take it as t. The derivative into dx will become dt. With chain rule, we'll multiply it with a. So we'll have 1 by a also. So finally, we'll have 1 by a integration t raised to n dt. I'm not showing steps because I expect everyone to know basic substitution. The answer to this will be t raised to n plus 1 upon n plus 1. You replace t with f of x plus b, and that is our final answer. The next question, students, 82, is pretty good. It will test your algebra concept. If you're very strong with algebra, you'll get through this sum quite easily. I'll give you one reference. You had a similar question last year in limits. I'm not sure if you recall that category or if you have ever come across that category. So let's take this question with that basic algebra concept. See, the issue with this question is we have a square root of x. We have a cube root of x. I hope you understand at least that x raised to half means square root of x. X raised to 1 by 3 is cube root of x. We'll have to get rid of both square root and cube root. Now see, you have to understand, to get rid of square root, we can substitute x as t square. But then the issue is cube root. So to get rid of cube root, we should substitute t cube. So the question is, do we substitute x as t square or x as t cube? What we'll do is, students, the powers are 2 and 3, right? What is the LCM of 2? The LCM of 2 and 3 is 6. I'll substitute x as t raised to 6. Now when we take the derivative of t raised to 6 is 6 t raised to 5. This will be dt. So this question becomes 6 constant. I'll keep it outside. T raised to 5 upon x raised to half, students, is square root of x, which is square root of t raised to 6. And this is cube root of t raised to 6. You keep solving this, students, further. This is 6. This is t raised to 5. This is t square. This is t cube minus t square. We can take t square common, students, in the denominator. We can cancel it with numerator. We get t cube upon t minus 1. And now it's normal integration skills. We'll need expansion formula at some stage. Because we have minus 1 in the denominator, I'll create that minus 1 in the numerator as well. We'll split this into two fractions, students. First is t cube minus 1 upon t minus 1. Second is 1 upon t minus 1. You solve this, students. T cube minus 1 is basically a cube minus b cube. So it is a minus b into a square plus ab plus b square. I hope you know this expansion formula. If you don't, well, this question can be tricky. And this is direct integration. We are done, students. Integrating this is easy. This is t cube by 3 plus t square by 2 plus t and plus 6 log mod t minus 1 plus c. Final step, students, you'll have to replace t with x raised to 1 by 6. And that will give you the final answer. So we're done with this. Some students will move to the next one, which is question number 92. Question 92 is actually a direct application of this rule, students. Integration e raised to x into f of x plus f dash x dx. This rule. We are going to use the same rule over here. If you're wondering what is this log 2 doing, the thing is actually in this formula, teachers might not have told you. Even I did not tell it to my students earlier. We have a hidden log e. We never discussed about it because log e is 1. At this point, we need to discuss about it. In general, the formula is integration a raised to x, f of x into log a plus f dash x is basically e raised to x into f of x. My bad. In this case, it will be a raised to x into f of x. So the answer to this is directly 2 raised to x into f of x plus c. Then we'll move to the next one, which is question 106. Question 106 has a slightly special approach. You need to understand this category. So we have a lot of powers over here. We have 4th root of x minus 1 the whole cube and x plus 2 the whole raised to 5. In these questions, students, the catch is, you have to remember that we will always try to take the term with the higher power outside the root. Over here, the term with the higher power is x plus 2 raised to 5. What I'll do is I'll try to convert it to x plus 2 raised to 8 so that we can take it outside the 4th root. Now, how do we convert it to raised to 8? So we can write this as x plus 2 raised to 8 upon x plus 2 raised to 3. Because when we use indices, this 8 minus 3 will be 5. We are basically multiplying with x plus 2, dividing by x plus 2 the whole cube in the square root. Now, students, we can take this x plus 2 raised to 8 outside. So we have 1 upon x plus 2 raised to 4. If you look at x minus 1 the whole cube, x plus 2 the whole cube, that is x minus 1 upon x plus 2 the whole cube. And because we have 4th root, I can write it as raised to 4. Now, what you have to understand, students, is this x plus 2 raised to 8, when it comes outside, it will be multiplied with 1 by 4. This is a mistake. Please make this correction. It's 8 into 1 by 4, which means we have 1 upon x plus 2 raised to 2. Now, students, for this term, I'll take it in the numerator and I'll write it as x minus 1 upon x plus 2, the whole raised to minus 3 by 4. We're using the rule of indices. When we take it in the numerator, when we take reciprocal, power becomes negative. Now, students, your derivatives skills will be tested over here. Now, in substitution type, I had mentioned that generally the term with a very complicated power has to be taken as t. See what happens if we take this as t. See what happens when we take the derivative of this. Derivative of this will be x plus 2 into derivative x minus 1, which is 1. Minus of x minus 1 into derivative x plus 2 is 1 upon x plus 2 the whole square. Students, the derivative of this equation, the fraction, is actually 1 upon x plus 2 the whole square. So now we get I is equal to, this whole term becomes derivative. So this is integration t raised to minus 3 by 4 dt. This is x raised to n formula, so x raised to n plus 1, which is minus 3 by 4 plus 1 upon minus 3 by 4 plus 1. You saw the students, solving this is easy. This will be t raised to 1 by 4 on 1 by 4, and that gives you the answer 4 into 4th root of t plus c. You substitute t at the end, and that will be your final answer. With that, we complete this question. Let's proceed to question 107. In 107, students, we have this modulus function. We have modulus of x square plus 2x minus 3. Now, students, we'll simplify this modulus function first. X square plus 2x minus 3. When you split the middle term, the quadratic splitting the middle term, you will get x plus 3 and x minus 1. Now, in these questions, students, I'll take the help of vary curve to decide where is it positive, where is it negative, because that will help me decide whether, when we remove modulus, should we write plus or minus. So now, students, we have, if you look at these two brackets, when you equate them with 0, the numbers into consideration are minus 3 and 1. The numbers in the question are 0 and 2. Our focus should be only from 0 to 2. Minus 3 to 0, this interval will not be checked because 0 to 2 is the interval given in the question. So now, students, from 0 to 1, you take any value. I'll take 0.5. When you substitute 0.5 over here, students, it's negative. If it is negative, I'll make it like this, and this will be the nature of vary curve. So, students, we split this into two parts. One is 0 to 1, other is 1 to 2. Now, in 0 to 1, students, because it's negative, when you remove modulus, it is going to be minus x square minus 2x plus 3. And this, students, will be x square plus 2x minus 3. It will be positive. And now, students, hereafter, I want you to complete this. You have to do basic integration and then upper limit minus lower limit. You will get the answer. The next question that we have is question 129. In this sum, students, question number 129. See, I don't like this x by 4. I'm going to remove the x by 4 and then proceed with the question. I don't want to work with x by 4 because I'll have to keep writing x by 4 in a lot of places. That will be too much work for me at least. You can decide it for yourself. Over here, what I'll do is I'll take x by 4 as t and remove it. It's not compulsory. You can just solve it with x by 4. I don't want to write x by 4 again and again. So here, students, dx is basically 4 dt. So this question is I is equal to 4 tan t upon 1 minus sin t. Now, see, if you're wondering how to solve this, you don't know what to do, the best thing to start with is convert it to sine and cos. If everything is sine and cos, we can do something with it. So this is sine t upon cos t into 1 minus sin t dt. Now, students, at some stage, we will be using a substitution. For substitution, derivative should be in numerator. Because we have 1 minus sin t in denominator, we cannot take cos t as t. We'll have to take sin t as t at some stage, which means we have to create cos in the numerator. How do we create cos in the numerator? We'll simply multiply by cos, divide by cos. So this becomes cos square t into 1 minus sin t. Can we convert everything else to sine, students? Can we convert cos square to sine square, students? I'm sure you know the formula. The numerator you keep copying as it is. This is sin t cos t. Denominator cos square t is 1 minus sin square t. And this is 1 minus sin t. You keep solving this, students. We have sin t into cos t. 1 minus sin square t is 1 plus sin t into 1 minus sin t using a square minus b square. This will become 1 minus sin t, the whole square, students. And now you take sin t as something. I'll take it as y. So cos t dt is dy. So now, students, this question becomes 4 y dy upon 1 plus y and 1 minus y the whole square. I hope, students, now you can recognize the type. This is partial fractions. I hope you know what is partial fractions, how to solve partial fractions. If you don't, you really need to practice it well enough. It comes in boards. So go ahead with this. You solve this completely. If you don't get the answer, you comment in the chat box. I'll get back to you. Let us proceed to one last question, which is question 130. Students, in question 130, in the numerator, you have to search for common. What is common in the numerator? In the numerator, we can take cot x common. In the bracket, we will have 1 plus cot square x. Denominator, students, do you see is a cube plus b cube because 1 is 1 cube. Now, a cube plus b cube formula is a plus b. So this is 1 plus cot x into a square minus ab plus b square. Now, students, we know what is 1 plus cot square x. In the numerator, I'll substitute 1 plus cot square x. That is cosec square x. Denominator, students, is 1 plus cot x into 1 minus cot x plus cot square x. Now, students, you take cot x as t. When you take cot x as t, derivative is minus cosec square x. And that is dt by dx. So from here, we'll get cosec square x dx is minus dt. So this integral becomes, students, minus 1 t upon 1 plus t into 1 minus t plus t square into dt. This again, students, is partial fractions. It's the fifth form of partial fractions because this quadratic cannot be split further. So you have to solve this with that fifth form where we use bx plus c. You complete this, students. You complete and check your answer. If you don't get the answer, you text me. I'll get back to you. With that, students, we complete integration. You'll have to practice all types of integration and only then you can master these difficult questions as well. Right. And with this session, I'll see you in the next session, the next chapter. Thank you.